Now, to refresh your memory, the SkyView Autopilot can use two different menu systems. This is a simplified menu. I'll talk about the expert menu a little bit in a moment, but we're going to learn how to use the simplified Autopilot. So we're actually flying here. Bob, I just want you to turn the Autopilot on. So let's start from scratch, turn the Autopilot menu up, and press this button, Track plus Alt. How simple is that? Do you hear the noise? This is the actual servos running a joystick controller, the same servos that are in your RV12s and the CTLS. So what do we see that's going on here? Well, this green button that means the Autopilot is engaged. Up here, here's the Autopilot Annunciation. Autopilot, green is on, left arrow, roll axis is on, right arrow, pitch axis is on. What's the roll axis doing? It's following the track bug, which is set at 186 degrees. And there's the track bug. It's holding my altitude at 10,000 feet. Pretty easy, right? Now, one thing I want to show you, I'm going to disconnect the Autopilot. He's disengaged. This is flashing yellow to say, hey, you're gone. If we had the audible system hooked up, Autopilot disconnect. Autopilot disconnect. Now, regardless of where the altitude bug and heading bugs are, go ahead and press the Autopilot button and watch the bugs. The bug snapped back to my current heading, current altitude. So in this mode, anytime you engage the Autopilot, it will reset those bugs to your current values. You might say, well, I want to be able to preset them on the ground, and it doesn't work that way. You have to use the expert menu if that's what you want. For the simplified Autopilot, we want it to be as quick and easy and simple as possible. One button, the Autopilot's in control. He's going there.
The level bug does the same thing.
Hang on, hold on to that thought. He's asking me about the level feature. I'll get there. So now, how do I get to this airport? We have this track line. How would I maneuver to this airport? Let's move the heading bug. Let's rotate the bug until it sweeps across this airport here. Go ahead, turn the heading bug. Well, there's one. Oh, there you go. So he's going to rotate that until this goes to that airport.
Where are we talking?
I want to go over here where my pointer is. Over
there.
Yeah, go to
My bad.
My bad.
Didn't see you.
Right there. So the Autopilot's flying. So once we pilots made up our mind, now the Autopilot can make up his mind which way to turn. But he's now going to this bug. It's not the same as that course line, because when I defined this direct to course line, the airplane was back here. And the Autopilot's not following this course line, he's following the bug. He's going to roll out right there. Yep. And likewise, if I wanted to change altitude, we would change our altitude bug. We would, there's an altitude bug up there, maybe go down to 8,000 feet. Autopilot just starts going down. And he will level off and hold that altitude. How fast is he going to go? Vertical speed, in this case, minus 500 feet. Where do we get that number? In setup, you define a default value for climb rate and a default value for descents. In some aircraft, your climb rate might be 500 feet, 800, 900 feet per minute. I don't know what your airplane can do. The RV12 can easily do 600 or 700 feet per minute climb. An astounding array of aircraft to fly an ILS, the glide slope, needs a vertical speed in no wind of how much? 400 to 600 feet per minute. I don't care if it's a Lancer that flies 300 knots or a Cessna 172. They need 400 to 600 feet per minute to fly the glide slope. It just works out that way. So you might define in setup, my default climb rate is 700 feet per minute. Default descent rate is 500 feet per minute. But you can change that. Remember, this knob has a vertical speed bug value, and I can moderate or increase the rate at which he's going to descend to that new altitude. Now somebody at lunch asked me, what's your name again? Your name?
George.
George. George asked me, yeah, but I want to fly a heading, not a track. So what is track?
Actually, ground track.
Ground track. Well, where did this track bug come from? We never had a track bug over there. We only had heading. There is no heading bug here. It says track. What's that about? Well, let's turn the autopilot off for a second. When the autopilot is disengaged, this bug is a heading bug. It's on the heading instrument. It's a magnetic heading derived instrument. It's a heading bug. I turn the bug, it's a heading bug. But as soon as I turn the autopilot on in this mode, track mode, it's the same bug, but we dynamically change the name of that bug to be track. Why? Because that is GPS ground track. Now, why do we use ground track instead of heading? I said I want to get to this airport. If I put the bug on that airport, that's where I want to go. Or I put my track to go outside some airspace so I don't drift in the airspace. If I'm flying a heading bug, it puts the magnetic heading there, but I got a wind coming from the left. My ground track is like this, right? And in VFR flying, we just want to get there. I'm going there, I'm going to the pancake breakfast, I want to get to the pancake breakfast. So I want to be able to point a bug there and have it take me there. In track mode, the autopilot says, well, the wind's over there. I think I need to point you this way a little bit to make sure you go to the pancake breakfast. So the distinction between heading and track is relevant in relation to the autopilot function. Now, in an earlier version of our autopilot, we gave you a choice, heading mode or track mode. I can't tell you how many calls I received. What the heck's the difference? That's a little bit shameful. If you'd had your flight review with me, we would have covered that. And I bet you even Tom might have expressed the distinction for you. So we said, you know what? The people that are using this for VFR, you just need to get there. Now, again, if I'm giving you your flight review and ATC says turn left 270 degrees for traffic, even though we're VFR, maybe we're getting flight following. Okay, so you reach up and spin the bug to 270 degrees. We go on for a little bit, then I go, hey, George, are we complying with ATC? Yeah, he said 270 degrees. I'm going 270 degrees. If ATC gives you a vector, to this day, it's a magnetic heading. It's a course vector, but it's magnetic, not ground track. Are you complying? No, okay, no. Well, tell me why and why not. Well, I'm actually flying the autopilot in track mode. He told me 270 degrees, but I'm flying a ground track at 270 degrees. As long as you articulate that to me, then that's okay. In the early days of GPS, they would assign you vectors. They know what the wind drift is going to be. The controllers have been dealing with us, all of us flying GPS for how many, a decade and a half or longer. They know that a remarkable number of us magically follow a ground track of 270. So they accommodate that. But just know that you need to know the distinction. In IFR flying, the distinction is very critical. Okay?
But if you tune off the track and altitude, then you lose your altitude.
That's another question. Another change we made from the earlier version is we used to allow you to turn on altitude hold separate from track. We did away with that. Why? Now, if you only install a roll servo and no pitch servo, you wouldn't have the alt option.
Right.
But if you have both servos installed, either they're both on or they're both off. You say, well, yeah, but there are times when I want it. Well, fine. Then you go to the expert menu, and I'll show you that in a second. In the simplified menu, it's either on or it ain't. Okay? We have a mode here called HSI plus alt. But remember, it's grayed out. I can't select it. Why? I got no HSI. So I'll come back to that in just a second. Let me talk about, we talked about vertical transitions. They just goes to the bug. It starts right away. As soon as you move the altitude bug, it starts climbing or descending at the rates as we defined.
Let me ask you a question.
Sure.
On that subject, what happens to the trim?
That's a great question. Nothing until you fix it. So actually, let me do this, which is my pitch servo. This is my pitch servo. Look up at the top. See how it says pitch slip? Now, if I were more subtle, what happens is the servos will, if I command a climb, the servos pull the stick back the same way you do. And if I don't do anything to trim for the climb, either the servo or me, one of us has to hold constant stick pressure. And if it's me, then I reach down and change the trim. If it's the servo holding stick pressure, he doesn't have control over your trim motor or manual trim or electric trim. So the best we can do is we enunciate up at the top here. If the servo is having to hold constant pressure to maintain that climb, we'll enunciate trim nose up or trim nose down. And if the trim is so far out that the servo actually starts to slip, like you saw a moment ago, we say, hey, the servo's slipping. We better adjust the trim. Now, in a moment, I'm going to talk about this autopilot control panel for the advanced autopilot. One of the built-in features that you'll see in the next, I think in the next firmware release, this has the ability to auto-trim the aircraft. If your aircraft has electric trim motors and you wire them through this autopilot control panel, then anytime the servo detects an out of trim condition, it will apply commands to the trim servo motors to correct that. But without this panel and without using the expert mode, you have to manually trim the aircraft.
And what happens if you turn off the autopilot or it turns itself?
It's extremely rare for the autopilot to turn itself off, but if you turn it off and the aircraft was not in trim, the aircraft will seek its trimmed condition. So yeah, you can get an abrupt control movement.
I read that it couldn't even overstress the aircraft. Is that right?
The autopilot cannot overstress the aircraft.
If you do not, whatever you suggest, you don't correct the trim.
You really have to have
How do
trim
you
out.
do that before you shut it off?
Aeronautically, I suppose that's possible, but in my judgment, the servo would start slipping before it commanded the aircraft into an out of trim condition in our aircraft, before it reached a condition far enough out of trim that it could cause that kind of damage. So I understand what your concern is. I don't believe the autopilot servos have sufficient authority to put the airplane that much out of trim.
In simplified mode, you do all the trimming yourself.
In simplified mode, you have to trim yourself, absolutely. And if you have Bush-type airplanes, Super Cubs and such, airplanes that change their energy state very quickly with changes in pitch, it's not uncommon to have to add some power to assist, add or delete power to assist with the climb or descent. You just have to. That's the way the airplane works. Now let me show you something though, since we're on that track. I've just cut the power, and by the way, but I still want to climb, so let's climb to 10,000 feet. Well, the autopilot's pitching up to execute a climb at my default value of 700 feet per minute. But watch what happens over here. Airspeed's low. Too low. What's he going to do? Well, you know what? I don't care how fast you told me to climb. I'm going to respect whatever you defined and set up as your minimum airspeed, which is 73 knots. That's how I set this airplane up. So the autopilot says, you want me to climb? Fine. I'm going to pitch up as much as I can, but when the airspeed gets to 73 knots, then I'm going to sacrifice your commanded climb rate to maintain that airspeed. So you're going down. You're not even maintaining altitude. We're going, I hate to use the term you're going down. We're descending. The airplane's doing the best it can. Same thing on descents. If you tell it to go down and it reaches a maximum airspeed, it'll pull up. Now, what if I had the airplane in extreme attitude and I turn the autopilot on? It'll try and pitch up, but there's another hard limit the autopilot respects, and that is G limits on the airframe. And the autopilot is hard-coded, and it will not pull more than, I think, 1.5 or 1.6 Gs. So it would fly into the terrain before it would overstress the airplane because of that. But the airspeed limits is a huge deal. Older autopilots did not respect airspeed limits, and you could put them in a state in which they would pitch up so much that the airplane would stall. That cannot happen with our autopilot. Okay, so let's put the power back in. So we did this, we did that. Two more features I need you to see about the autopilot. The way we normally fly with VFR is so the autopilot is flying along. Actually, let me disengage. Well, re-engage the autopilot. So we're just flying along, and they say, I want you to turn left 30 degrees for traffic. One way I can affect that, rather than turning off the autopilot, is I'm holding the disconnect switch. I didn't just push it and release. I'm holding it down, and as I turn left, however far I want to go, let's say he wanted me to fly 200 degrees. when I roll out, when I release the disconnect switch, it re-engages the autopilot and resets the bug to my new value. Right? So as long as I was holding the disconnect switch down continuously, it was in a suspended state we call control wheel steering. And as soon as I roll out and press it, release it, it turns it back on, resets the bugs. Same thing if the autopilot isn't yet engaged, no matter where I'm at, typically when I depart VFR, I climb to my altitude, roll out of my heading, and then if I don't want to press the autopilot menu on the display, but I got a disconnect switch on my stick, I would just press and hold the disconnect for 3 seconds. 1001, 1002, 1003. I let up, the autopilot is just on and those bugs are set. Okay? So again, for those of you that have only one screen and you don't want to have to switch menus, you don't even need the autopilot menu in this way. You just hold the disconnect switch down.
You can have a stick control.
Yep. Now, in certified autopilots, the disconnect switch has to be on the control wheel or stick. We can't compel you to do that, but it's a pretty good idea. RB12, they put the disconnect switch on the panel. I can't change that. That's not up to me. If it was me, I would rewire it on the stick, but just know that that's where it's at. Okay, how are we doing? Additional autopilot modes. Now we got to talk about these. Still got to get back and talk about the HSI, but we'll skip that for a moment. How many of you listen to country music? Another off-the-wall thing. You like it. There's a song by Carrie Underwood called Jesus Take the Wheel. Jesus take the wheel. So let's turn off the autopilot. Let's say I'm in an unusual attitude. Now, Bob, reach over and push the level button.
This is the equivalent of Jesus taking the wheel?
Yeah.
Yep. Not on here, you have to do it on there.
No, it's not on.
Interesting thing, Bob was pushing the autopilot control module. That module does not work unless we use the expert control scheme. But when you press the level mode, it doesn't matter what the airplane's doing. It's going to execute an unusual attitude recovery. It resets the bug values, but it ignores them. What it does is roll to bank angle 0 and pitch to vertical speed 0. Even though it reset the bugs here, it doesn't care about the bugs. It disregards the bugs. Because what would happen if you were zooming up when you press that button, it reset the bug value here, but you zoomed up to the altitude, and then it rolled the wings level. You don't want to pitch back down and go hunt for that altitude. You just want things stabilized. So even though it resets the bugs, it disregards them. Bank angle 0, straight, vertical speed 0, level. Okay? But it'll still respect airspeeds and G limits and all that. Then the other mode you see up here is 180 degrees. So press that one, Bob. Where's this going? Well, in this case, notice when you press that button, the Trackless Altitude button comes on. They're related. They're essentially the same except for the heading bug, track bug, gets set to the 180 degree reciprocal. Why would you use this? Inadvertent flight into IMC. I don't know for sure where things are better, but I know the last place it was better was right behind me. So 180 degree button. It sets the altitude bug and holds the altitude. It sets the heading bug 180 degrees out and goes. And standard rate or maximum bank angle that you define in setup. And does it always turn, you asked me if it always turns right. It almost always turns left by design. But there is one circumstance when it'll go the other direction. But before it does, watch what happens here as we roll out. Watch what happens to the Autopilot Annunciation. That button goes dark, and then the autopilot continues on in the track plus alt mode. So that's why those two are related.
Will it turn into a terrain if you go out, right?
Yep, without regard for terrain. The system does not yet do terrain avoidance in that way. I got to leave a few things for you to be responsible for. I'm giving you a lot of value in this system. There's a handful of things I'm still going to rely on you to do. You lazy son of a gun.
Does the level button work if the autopilot has not been turned on?
Absolutely. It absolutely works. And by the way, Bob reached up to push the button on this panel. This panel won't work. However, this function, the level function, is the one autopilot thing, other than the disconnect switch, this is the one autopilot function that can be wired to an external button. And in fact, In the Glacier Sportsman, our club airplane, we have a big blue button in the middle of the panel. It's right above the pilot's EFIS. Big blue button, and you just hit my hand. You hit it, and Jesus, take the wheel. So here we are. The autopilot's not turned on, regardless of the attitude. Hit the level button. So the autopilot wasn't engaged, but now it is. What?
Autopilot's not engaged, you press that, it automatically engages in correction.
Yeah.
It's like
Yep. Panic button, 180 degrees. So I am going to explain to you the differences between the simple autopilot menu we just saw and what the expert control scheme looks like. Now, first of all, you have to select it in setup. So I'm going to pause my screen, and I'll show you what that looks like. When we press and hold buttons 7 and 8, his hold to enter setup. Now, because I'm in flight, the system says, are you sure you want to go into setup? There's only a couple things you should do if you're in flight. And by the way, I'm leaving the flight instruments over there. So you might want to change the pitch angle adjustment. That refers to this guy here. It's like running the little aircraft symbol up and down on your attitude indicator. You would do that to adjust for weight, for heavier weight loadings where you need more angle of attack in cruise. Make sense? The other thing is autopilot setup. Those are really the only two things you should be screwing around with in flight. So when I choose this, now I would choose the autopilot controls and switch to the expert menu, and I'm going to press button 8 to accept. Now when we back out and look at the autopilot menu, now it looks a lot different. So here are some things that are important to know. The autopilot with the advanced setup has 3 menus. There's a main autopilot menu, and here's where I would turn it on. If I press this button, it would just turn it on. This is the flight director. Do any of you know what the flight director is?
Yes.
Okay, so I'm going to skip it because we don't really need to know that. Here's that level button. But then there's separate menus for roll and pitch. So that's one departure. You have to control the axes separately. By the way, on the roll menu, you do have access for heading mode and track mode separately. If that's important to you, that's where you get it. But on the pitch menu is where things get a lot more complicated. You have to tell the system, do you want to climb with respect to a vertical speed? We did that before. Or you can climb with respect to an indicated airspeed mode. And by the way, if this autopilot is holding an altitude and you move the altitude bug up, it says, okay, I know that's where you want me to go, but I'm not going there till you choose one of these modes. And even if you choose one of those modes, when you press that button, it defaults that parameter to your current value. So if I'm straight and level and I raise the altitude bug, press vertical speed, it still says vertical speed 0, and then I have to change the bug value. So it can take 2 or 3 steps to accomplish what we did previously by just changing the altitude bug.
Do we still observe your limits?
Same limits all still apply, but it requires more forethought by you, the pilot. So are you getting a sense of how that's more complicated? There's more capability, and the autopilot in this mode can follow vertical guidance from a glide slope or a glide path, but you have to invest more of yourself to understand how it works. Okay? And there's other things like mode sequencing, where you're flying on a bug, but it's prepared to intercept the localizer when it senses it and all of that.
Can you use the flight director when you're hand flying?
Absolutely. In this mode, if you have the autopilot set up in the expert mode, then you can turn the flight director on, and that's those magenta bars there. Now, it has no other guidance, so that's why they're kind of locked together. But it would work properly if we had course guidance going. So that's really all I wanted to show you. Oh, last thing is the control panel. I think you have this installed in your airplane. I don't think you have it. But it is up here in this panel. So what you would see if you look at these 3 menus, the main autopilot menu, roll, and pitch, all of the items that you would select on those 3 menus are accessible on this one panel. So if you are planning to add that, and you're willing to deal with the additional complexity, this panel is a very good way to get access to it all. So that's all I wanted to say about that. I'm going to reset this back to the simplified menu because we have to figure out how to finally fly with the HSI. Okay? Oh, shoot, I'm not there yet. One more thing to go. Do you remember when I was talking on the map, screen, map, I was talking about, do I have it up here? I don't have it populated, but there was that field called vertical speed required, which kind of gives you vertical guidance. Say, if you want to get down to pattern altitude within a mile of the runway, start down now. So that's what this magenta line here is telling us, is with respect to our flight plan, if I want to arrive at that waypoint, this says that's the vertical speed I would need, and I would pitch down to that. Now, some of you may have experienced in handheld GPSs, you can do something similar, the 6 or a 3.6, but what they do is they actually output vertical guidance that looks like a glide slope or glide path right here. And they put out that guidance continuously until you get within, I think, 600 feet of the ground or whatever it is. We don't do that. And frankly, that guidance scares me a little bit because it lulls the VFR pilot into thinking that you've got true vertical guidance. All it is a mathematically calculated descent slope without regard for terrain clearance, right?
So it's a standard 3 degrees.
So I don't know what mathematical slope they use, but yeah, it's a standard slope that they calculate. Say, oh, if you want to go down at 400 feet per minute and you want to get down by here, here's where you go. And they put out this guidance. It looks just like it's the same dot that you would get from a glide slope. And it scares me that VFR pilots are relying on that, maybe flying at night or something, because it doesn't respect terrain avoidance like an approach instrument would. So we took a different approach. We give you this guidance. It'll get you the same thing. You still need 400 feet per minute, but you're responsible for flying it. And in my judgment, that gets you more mentally engaged. Remember, I need to keep you doing something, right? So I think that kind of guidance keeps you more engaged. And then there's one other kind of cool feature. Watch on the map as I change the altitude bug. Do you see that blue bar coming across there? That bar you see on my projected glide path says, at my current vertical speed, and with the altitude bug set above me, that's the point on the map where I will arrive at the altitude represented by the bug. So if you're attempting to climb above some airspace ahead of you, you'd say, oh, the ceiling of that airspace is 10,000 feet. I'll set my bug at 10,300, and if that's the boundary of the airspace, I'm good to go. If it's out here, then I need to climb faster or something. Does that make sense?
No, because you're losing manifold pressure on the way up.
Well, it's not a linear thing, but that's complicating things unnecessarily.
Does the autopilot have to be on for that?
Nope, the autopilot's not engaged now. We're just flying. All I did was adjust the altitude bug. Notice if I change the bug back to where I'm at currently, the banana goes away. Do we need another break?